Alrighty, so this is a review for my IM2 classes on factoring. So you have an EST coming up on factoring completely. So let's go ahead and do some practice problems. Remember that throughout the video, I expect you to attempt the problem on your own first. And if you get stuck, then maybe watch the next step and then pause again and see if you can finish out the problem. I also expect you to watch the video, even if you think you did them all right. I would do number one, watch me do number one, and then you go try out number two, and then watch me do number two, just so you can check your work. And you can always kind of skip through parts of it, but please make sure to show all of your work, okay? So make sure you guys write your name. I'm just going to write video here. So here's the first one, and please also remember that I will be moving relatively quickly, so make sure to pause the video so that you don't feel like you're behind. So here, the first step that I always do with these is first see if it is factorable. So I'm going to draw a little arrow down, so n squared times 12 is 12n squared. And my bottom here is going to be that negative 7n. This is because we always put the bx term in the bottom, because if we have an area model, we want to make sure that our diagonals not only add up to equal negative 7n, but also multiply to be 12n squared. Our other two diagonals would be this one and this one here. And I'll show you how that setup is once I show you how to determine if it's factorable or not. So here, I need to be able to find the two missing pieces here and here. Okay, those are my two factors. So I have to consider what numbers multiply to give me 12. Well, I always start off with 1. 1 times 12 is 12. 2 times 6 is 12. And 3 times 4 is 12. And then it just starts repeating. 4 times 3 and so on. So we have to pick which two factors will somehow give us a negative 7. Looking here, I see that I have 3 and 4, and if I make each of them a negative, they multiply to be a positive 12n squared, and they add or they combine to be a negative 7n. So this tells me that it is factorable. If I found these two factors here and here, I have a factorable quadratic. So now I can draw my area model, and you can always draw your area model to start, but usually I recommend waiting just in case something is not factorable. I believe for the purposes of this video, I chose quadratics that were all factorable. So, alrighty, so the first box, we always want to put that n squared. Okay, the n squared goes here. And then the bottom right box is the 12, or my C term. And then I have my factors here, negative 3n, and then negative 4n. And the reason why we have to do this is because in the very beginning, if you remember, I showed you guys how the products of the diagonals are equivalent. So 12 times n squared equals 12n squared. So I needed to set up my diamond to split up that negative 7n as my bx term to be a product that equals 12n squared as well. So negative 4n times negative 3n is positive 12n squared. So you see here our products are equal to each other, the products of the diagonals. That is why we have to use the diamond. Okay, so now here if we factor, if I'm looking at what is the GCF of these two terms, well, the coefficient of n squared is just 1, so the coefficient GCF is just 1, but they also both have an n. So really, you guys can just write n. Instead of 1n, it's just an n. Okay, and now that I know that I have to multiply this n by something here to give me n squared. The only something I can multiply it by is n. So I know this one is also n. And you can look here and see the GCF between n squared and negative 4n is n. So now I can start looking and seeing, okay, so if I know this is n, what do I have to multiply the n by to give me negative 4n. Or you could even look and see, okay, what is my GCF between negative 4 and 12? Our number that needs to go here is a 4, and we know it needs to be negative because n times negative 4 equals negative 4n. Okay, so this has to be a negative. And then down here, I know n times what is negative 3n. This is going to have to be a negative 3. So now we can go ahead and check it and make sure, okay, if I have negative 3 times negative 4, do I get positive 12? Yes, I do, right? And you can do it for all of them. Negative 3 times n is negative 3n. Yep. N times negative 4 is negative 4n. Yep. N times n is n squared. Yep. Okay, I won't do this the entire video just to try to keep it under, not make it too long. But make sure that you check your area models every time. So our factored form is n minus 4 times n minus 3. And again, you guys might have set up your factors different. Maybe you switch these two. So that's totally fine. You would have just had n minus 4 over here and n minus 3 here instead, but you should still get the exact same factors. Doesn't matter their order. So again, this is what we would call a standard form here. And this is factored form. Okay. I want to remind you guys as well that the standard form of a quadratic is ax squared plus bx plus c. So if you hear me saying like my a term, that's the ax squared. The a is the coefficient. It's the number in front of x squared. Most of the time, like this one here is just a 1, right? And it's okay that we have n's instead of x's. It's just any variable. The bx term is what we have to split, the red one over here. And then the c term is always multiplied by the ax squared term. Okay, so now I'm going to start going through them relatively quickly. So make sure that you guys are pausing the video, try it on your own first. The first thing I'm going to do is set up my diamond. A squared times 63 is 63a squared. My 16a goes at the bottom of my diamond. 16a. So now I need to consider all of the factors of 63. I always start off with 1. So basically you think of like, okay, 63 divided by 1 is 63. 63 divided by 2, that doesn't work because it's not an even number. But 63 divided by 3 works, so that's going to be 21. 4 does not go into 63, and neither does 5, neither does 6. 7 does, right? 63 divided by 7 is 9. And then it just starts to repeat 9 times 7 and so on. So that's whenever I know I need to stop, okay? So 7 and 9 look like those two are the only two that are going to add up to 16. And luckily all of our numbers are positive, so we don't have to worry about any negatives in this one. So this is going to be 7a and 9a. So now I know, okay, yep, it is factorable, so I'm going to go and set up my area model. And remember that the first box is the a squared term. And then our bottom right is the 63. And then my factors go in the other two diagonals. There we go. Okay, so I want you to try to factor this on your own. Don't forget, you should be trying these on your own and then checking my video to help you and make sure that you did them right. Okay, so my GCF here, a squared and 9a, is a. My GCF here between a squared and 7a is also a. Okay. And then my GCF here, 9a and 63, both of those are divisible by a 9. You can also see, okay, a times 9 is 9a. So that's another way to put it. since we already know that that term up there is a. And that's a positive 9. And then here, my GCF between 7a and 63 is a 7. So my final factored form is a plus 9 times a plus 7. And that is the factored form. Okay, make sure you pause. All right, here's another one. So again, the first thing I do is set up my diamond. K squared times negative 12 is negative 12k squared. And then that 4k goes on the bottom. So I'm going to have a positive 4k. So now I want to see, okay, I need to get a negative 12 and a positive 4k. So all my factors of 12, I start off with 1. 12 divided by 1 is 12. 2. 12 divided by 2 is 6 because 2 times 6 is 12. 3. 12 divided by 3 is 4 because 3 times 4 is 12. So I know that one of these need to be a negative, right? In order to make that negative 12 up top, the product, it has to be a positive times a negative, okay? So here, if I'm looking to get a positive 4, I can use the 6 and the 2. And then I have to think, okay, well, which one needs to be positive in order for me to get a, or which one needs to be negative or positive in order for me to get a positive 4? Well, 2k minus 6k would be a negative 4. So I know that's not right. So it needs to be a positive 6k and a negative 2k. 6 times negative 2 is negative 12, and 6 minus 2 is a 4. So now I can go and set up my area model. Okay, so we have k squared, it's the first box. Negative 12 is the bottom right box. And then I know that my diagonals are 6k, oh, not that, 6k and negative 2k. So go ahead and take a moment to try to factor this on your own, if you have not already. So here, k squared and 6k, they both have a k in common, no other coefficient besides 1. Same thing here, k squared and negative 2k, their GCF is a k. Now here I have 6 and 12. That would be a 6. They're both divisible by 6. Here I have both of my negatives, so I'm definitely going to pull out a negative. And those terms are both divisible by a 2. So negative 2. And again, you can check, is 6 times k 6k? Yep, right? 6 times negative 12, or I'm sorry, 6 times negative 2, is that negative 12? Yes, it is, right? K times negative 2, is that negative 2k? Yes, and so on, okay? So our final factored form here is k plus 6 times k minus 2. So be sure to pause before I move on. All right, here's another one. So again, I set up my diamond first. Okay, I'm going to color code real quick so I can kind of just like copy the diamond. So give me just a second. I'm just going to kind of set up the color coding and see if it helps me go a little bit faster. I'll even set up the area model. So I know, because I'm the teacher who created this, I know that all of these are factorable. So I'm just going to go and set that up just to kind of save us some time in the video. All right, so this is just my setup just with my colors and stuff. So let me go ahead and copy that. All right. Okay, so x squared times 50 is 50x squared. And then the bottom needs to be that 15x. So I have to look, some of you already know it, but I'm going to go through the motions of finding all the factors of 50. 1 times 50, 2 times 25, 3 does not go into 50, 4 does not, but 5 does, 5 and 10. So we can see right there that our factors here are going to be the 5 and 10. Okay, so I have 5x times 10x equals 50x squared. 5x plus 10x is 15x. Okay. So here I have my x squared and my 50. X squared goes in the top left of the area model, 50 goes in the bottom right. And then I have 5x and 10x. So my GCF between these two factors, or these two terms, x squared and 10x, is just x. Same thing here. The GCF between x squared and 5x is just x. X times x is x squared. This one has to be a 10. The greatest common factor here is a 10. And x times 10 is 10x. This one here must be a 5. 5 times 10 is 50. 5 times x is 5x. And the GCF between 5x and 50 is 5. So our final factored form is x plus 10 times x plus 5. Be sure to pause the video. Alrighty, so this one is a difference of squares. So I'm going to do this one both ways actually. So if we wanted to use the normal diamond and area model, you would have to add in that 0 in, the bx term, in order to be able to factor like normal. So I'm going to do the shortcut over here, and then the diamond and area model here. Okay, so let me go ahead and paste what I have here for that. Whoa, it's big. There we go. Okay. There we go. Alrighty, so for the shortcut, this is called a difference of squares. Difference of squares. We discussed this in class, but you could always look it up again to try to get a more solid understanding of that. Difference of squares. Okay, so here, difference of squares, we always have the first factor term with the positive in it, and then the second one with the negative. The first part of it, you take the square root of n squared, and that is what goes into the first two parts there. So the square root of n squared is just n. And then the square root of this term, 25, we just ignore the negative for this one, is 5 and 5. So this is the factored form of n squared minus 25 if you recognized that you had two perfect squares and they were subtraction there. Okay? So now let's do it this way. So over here, n squared times negative 25 is negative 25 n squared. And 0 n goes on the bottom. So you need to try to find two numbers that multiply to negative 25 and add to 0. Well, the only way we can get 0 is if we subtract something from itself. So the square root of 25 is 5, because 5 times 5 is 25. So I'm going to have a positive 5n and a negative 5n. So I'm going to remind you that n squared goes in the top left, negative 25 will go in the bottom right. And then I have positive 5n and negative 5n. So my GCF here is an n. Their coefficients do not have any common factors besides 1. Same thing here, my GCF is an n. And here it will be a 5. And it's going to have to be a positive 5 because my n here times positive 5 will give me this 5n inside. Okay, so it's going to be plus 5. And over here, these two are both negative. So that up there is going to be a negative 5. And if you double check everything, it should check out in your area model. So our factored form is n plus 5 times n minus 5, which is the same thing as we got over here. We just used the shortcut over there on the left. But again, I highly recommend that you do not do the shortcut unless you are 100% sure that you see the pattern every time, whoops, and that you understand why we can use that shortcut for difference of squares. Okay? Moving on. Here's another one. P squared. is a perfect square. P times P is P squared. 1 is also a perfect square. 1 times 1 is 1, okay? So I will do the shortcut again for you. In this whole, whoops, do that. And this whole thing as well. So here I would have P squared, and then plus 0n, or I'm sorry, plus 0p, I was still thinking of the last problem, minus 1, okay? So this is the shortcut, again, for difference of squares. And this is the diamond and area model, which works every time. All right, no matter what you have, as long as it is factorable, right? As long as we find the two purple factors, we can use this every time. So let's go and see what we end up with. I'm going to go ahead and do the shortcut first. So with difference of squares, I know it's going to be some quantity plus something, and then minus something. So the first box I do, I take the square root of p squared, and that is what goes here and here. The square root of p squared is just p. And then I have the 1. Square root of 1 is just 1. 1, 1. And I want to show you guys real quick why we know this works. If you want to check your work for something like this, you can always set up an area model and multiply those two terms by each other. P plus 1 times P minus 1, I get P squared, 1P, negative 1P, and negative 1. I notice here that 1P minus 1P cancel out to 0. So all I'm left with is P squared minus 1, which is exactly where I started. So I know that I did factor this correctly using the shortcut. All right, but let's go and do the diamond and area model. P squared times negative 1 is negative P squared. The 0P goes on the bottom. So here I have, this is a negative 1 here, okay? So I have to see, okay, well, 1 times 1 is 1, so 1P times negative 1 is negative 1P, and 1P minus 1P is 0P, okay? So here I'm going to go and color code again for my area model. So I have P squared, negative 1, 1P, and negative 1P. So now if you go ahead and factor it, these two, the GCF is a P. These two, the GCF is a P as well. And then this one has to be negative 1 because this GCF is negative 1 and P times negative 1 is negative 1P. Therefore, this one must be a positive 1. So my final factored form is P plus 1 times P minus 1. Please make sure you are pausing and trying these problems on your own. All right. Here's another perfect square. So this one, or I'm sorry, difference of squares is what we call it. Okay, so I'll go and do this again. Just so you can see like both ways. I'd like to show you guys both ways. Okay, so this one I have to put 16x squared and negative 25, and I have to put that 0x inside in the middle so that I have a standard form of a quadratic here. Okay, so here, if I wanted to do the, let's see here, if I wanted to do my difference of squares, I know I'm going to have a setup such as this, because that's the only way that that bx term would cancel out. So here, if I were to take the square root of 16x squared, again, this only works because I know this is a perfect square. 4x times 4x equals 16x squared. And then I know 25 is a perfect square. Square root of 25. So we have 5 and 5 here. All right, so this should be my factored form. So let's make sure we get that with the standard factoring with the diamond and area model. So 16 times negative 25 is negative 400. And then we have 0x down here. So we know that these two factors must be the same just one of them is a positive and one of them is a negative in order to cancel out to 0. So what you want to do is take the square root of 400, because that means whatever this is, it was multiplied by itself to get 400. So 20. And this is because 20 times 20 is 400. So positive 20x minus 20x gives me 0x. Multiply them, you get negative 400. So here I have my top term, my bottom right term here, 16x squared, negative 25. My purples, I have 20x and negative 20x. So this one's different than the ones we've been doing because we do have a coefficient other than 1 for the x squared. So the GCF between 16x squared and negative 20x is going to be 4x. They are both divisible by 4, and that's the highest factor they have in common. In order to get 16x squared here, this also needs to be a 4x. You can also see that the GCF between 16x squared and 20x, once again, it's the same as 4x. Right here, I see that I have both of my negatives there. So I know this term up here will be a negative. And the GCF between 20 and 25 is a 5. Or I know I have to do 4x times negative 5 to get me that negative 20x. So this one must be a positive 5. 5 times negative 5 is negative 25. So it does look like we got the exact same factors as if we had used the shortcut. But again, if you don't recognize an example of a difference of squares, then you should always just do the regular diamond and area model. Okay. So here is a factoring one. So we want to see, is there a GCF? It doesn't look like it because like all the factors of 9, we have 1 times 9 and 3 times 3. 24, we have 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then it starts to repeat. And then 16, we have 1 times 16, 2 times 8, and 4 times 4. So if you guys look at that, we have to have a common factor between all 3 of these. The only common factor we have is a 1 between all 3 of them. So this one, there is no GCF. No GCF. So we're just going to factor like normal. Okay. So here, 9 times 16 is 144. So we have 144r squared. The 24r goes on the bottom. So we have to find what 2 factors multiply to 144 and add to 24. Okay, so we're going to start making a little chart here of all the factors of 144. I'm going to kind of show you guys how I do this. So if I were to have my little Desmos calculator here, there we go. So my factors of 144, I'll bring it down here, make it a little bit bigger. Whoops. Okay. I know, oh wait, no, I don't know what I'm doing. Hold on, guys. I realize I'm going to need more room than this probably, just because it is a large number. So 1 times 144 is 144. 2, if I do 144 divided by 2, that's 72. Let's see if it's divisible by 3. Yep, it sure is. So 144 divided by 3, 3 times 48 is what it would be. 144 divided by 4 is, yep, it is divisible by 4. So 4 times 36. Okay. I know it does not, 5 is not a factor of it because it does not end in 5 or 0. So let's try 6. 144 divided by 6. Yep, that is another factor. So it's 6 times 24. Let's see, 144 divided by 7. Nope, that's a decimal. That's not a factor. About 8. Yep. So we have 8 times 18 is 144. Okay, let's do 140. Whoops. And then we have 144 divided by 9. Yep, is 16, so 9 and 16. Oh, 144 has a lot of factors. Oops, 9. And then it's not divisible by 10 because it does not end in a 0. And 11, I don't believe it is either. Let's see here. Nope, that's a decimal. So 12, I believe, is our last one. Yep, 12 times 12. And then it would just start repeating. Then I'd go on to 16 times 9, 18 times 8, and so on. So these are the factors. Now I have to find two of them that also add to be 24. Some of you might already see it, but I'm going to show you how you can do it if you don't already see it. So I keep moving this little purple dot. So if I were you, I'm going to scroll down just a little bit. And now we're trying to figure out, okay, like what is the factor, right? What are my factors that also add to 24? So what I would do is just write right next to them, 1 plus 144 is 145. 2 plus 72 is 74. 3 plus 48 is 51. This one's 40, 30, 26, 25, and 24. So you guys see here, we only had one pair of factors where our sum is 24. So that is going to be 12 and 12. Okay, so that's another thing you can do if you're having a hard time with like the bigger numbers and you're having a hard time trying to find the factors, you can always do that. All right, so I know that this is going to be 12r and 12r. So I have 9r squared, 16 here, 12r and 12r. It's nice because they're all positives. So my GCF here between 9 and 12 is a 3 and then r. So this one must also be 3r. Between 12r and 16 is a 4, a positive 4, which is nice. 12r and 16, positive 4. So this one worked out really nicely. So this can be written as 3r plus 4 times 3r plus 4, which is also equal to 3r plus 4 squared. So this is what we would call a perfect square trinomial. Okay, you guys notice that my first term, the 9, and my third term, the 16, are perfect squares, right? So here we have a perfect square, 3r plus 4 times 3r plus 4, and we're good to go. Okay, so be sure to pause. Let's move on to the next one. Okay, so here we go. So we want to see if any of those have any common factors. So we want to see, is there a GCF? So if I were to set up t-charts, see all my factors, 6, 1 times 6, and 2 times 3. 42, I have 1 times 42, 2 times 21. 42 divided by 3, yep, 3 times 14. 4 does not go into it, but 42 divided by 6, yep, is 7. So 6 times 7. And then 48, same idea, 1 times 48, 2 times 24. 48 divided by 3, yep, 16. 3 times 16. Okay, 4 does go into it, 4 times 12. 5 does not, 6 times 8. And I believe that's it. So if you guys look here, every single one besides 1, right, besides the factor of 1, every term has a 6 as a common factor. So our GCF is going to be a 6. Okay? So here, what we have to do in order to do that, we know it's going to be 6 times whatever's left. So if I factor it out, that means I have to divide each term by it to see what's left inside. So 6x squared divided by 6 is just 1x squared. 42x divided by 6, 7x. 48 divided by 6, negative 8. Okay? So now we just factor what is left inside. So here, if I'm going to set this up, right, make that a little bit bigger. Here, I need to move a few things real quick. Let's move this up. Ay. Okay. There we go. Okay, that's much better. All right, so x squared times negative 8 is negative, whoops. Ay. There we go. Struggle. Okay, is negative 8x squared. The 7x goes on the bottom. All right, so let me go and color code a few things for you. Okay, so negative 8x squared and 7x, our factors would have to be 8x and negative 1x. And I'm doing this a little bit faster because I need to get ready for work. So the green is x squared, orange is negative 8. We have 8x and negative 1x. Our GCFs here is x, negative 1, x, and 8. So hopefully you guys pause to actually, see how to do everything. So the way that you're going to write your final answer, you have to make sure that your GCF is there. So it's 6 times x plus 8 times x minus 1. That would be your final factored form. So be sure to pause the video. This one right away, I know that each of them are divisible by 5. So my GCF here is a 5. So if I pull out a 5 here, divide each of these terms by 5, right? So if I have 5x squared divided by 5, I'm left with x squared. 75 divided by 5, get 15. It's a negative. And then 250 divided by 5, I get 50. So plus 50. Okay? So now I have to factor what is left inside. All right? So here I have, let's see here. I'm going to go in color code real quick. So that's my x squared, my bx term, my c. X squared times 50 is 50x squared. The negative 15x goes in the bottom. And I know negative 10x times negative 5x is positive 50x squared. Negative 10 minus 5 is negative 15. So now we just need to factor what is left here. My GCF here is x and x, negative 10 and negative 5. So our final answer, I have to include that GCF of 5 and then multiply that by x minus 10 times x minus 5. So again, I hope that you were pausing throughout the video, showing all of your steps and learning how to do this on your own because you do have an EST coming up. Okay, so this is great review for you, and I hope it was helpful. Have a great rest of your day.